Hello, how are you?
Good afternoon, sir.
You're welcome. That's Aloba. How are you?
I'm fine, sir.
Good
Okay.
afternoon, sir.
Yes, I can see where Rachel. How are you? Where?
Fine, sir.
As can still see you. It's
Good afternoon,
I see
sir.
Okoro. I see Okoro Chris. Yeah, I can see
Good
Mohammed.
afternoon, sir.
Ahmed, yeah,
Yeah,
good afternoon. Good
this is
afternoon.
Andrew. This is
Yes,
Andrew,
I've
sir.
seen it. I've seen Zoom users, I've seen Ebe Matthew, I've seen Rachel, I've seen Batmus, Deborah, Gabriel. You are all welcome. So without waste of time, my name is Professor Nabuko Konedi. So I shall take you through this course, facilitation through this course for the next 7 weeks. So our regular meeting hours shall be 5 to 6 every Saturday. If by any changes that I'm not around or we cannot take a given Saturday, I will always send a message across to you. So without wasting time, I think we should start. Without wasting time, we will start this lecture. I will have to mute everyone. I think I'll have to mute everyone. Can you mute yourself, please? Can you mute yourself? Mute yourself.
Already I have moved.
All right. Everybody mute yourself, please. So this course is called Introduction to Physical Chemistry, and that is course code is 103. As I said, my name, your facilitator is Professor Nabok AD. So we are operating from a National Open University platform. So, and for today's facilitation, we shall strive to know what is physical chemistry, because this is the first time you are taking physical chemistry as a course. So we'll see what is physical chemistry. We try to know why this study of physical chemistry is necessary. Why is it necessary that you should study physical chemistry, even when some of you are not chemists? You know the various units of measurement, because that's a starting point. We measure volume, we measure mass, we measure different things. What are their units? And what's the standard unit? And then we go to separation methods and their application. What are the various separation methods and their application? Along the line, we should take some questions, we shall treat some questions, and that we will do that. So physical chemistry applies modeling techniques, and the modeling techniques, we know it will involve mathematics, it can involve statistics, it can be computational. That means you apply mathematics techniques, you apply statistical techniques, you apply computational techniques to explain the feasibility of a chemical reaction and predict theoretical model for known process. Now let's take an example. We are working to see what will be the rate of reaction. So we measure concentration of a reactant A and we measure concentration of another reactant B. Now A and B react. We now measure what you call rate of reaction. So we come up with an equation, a mathematical equation that relates the rate of reaction with time or with concentration. Such is defined as model. That's creating a relationship, mathematical relationship, or a statistical relationship, or even computational chemistry relationship between variables. That's between one variable and another, in order to explain the process. So whenever I have the rate of reaction, or whenever I have concentration, I will now insert into that value and say, this is what my rate of reaction will be. So we use theoretical models to represent what happened in experiment. That's the study of physical chemistry. So reactions that are possible under stated conditions are said to be feasible. When we say a reaction is feasible, that means it's possible. That means If I put, feasibility is different from spontaneous reaction. Spontaneous means that once I keep that, I put the reactant on ground, it will react. But feasibility means it's possible. Maybe after, if I apply temperature, if I increase the temperature, if I increase the pressure, if temperature is not possible, we say it's not spontaneous. But if I increase the temperature, it's possible. But now, if I put it, no matter what I do, it doesn't occur. So we say such reaction is non-feasible. No matter how I change the variables, no matter how I heat it, how many hours I heat it, no matter, it's not possible that there should be reaction feasible. So spontaneous reaction is, for instance, I now keep an ice block on the table, it will melt. Whether you like it or not, it will melt. That is spontaneous. That means it occurs on its own without any external aid. But now, if I put water, water will never turn to ice block. So that reaction is not spontaneous. It will not occur on its own. But if I now put the water in the fridge, it will now turn to block. So it means such reaction is feasible. We can see the difference between feasibility and spontaneous reaction. So in spontaneous reaction, it will occur on its own without any heat. But any reaction that is very possible at all, maybe by changing condition, maybe by chilling or by increasing the temperature or by altering the pressure or any other treatment or by using catalyst, such reactions are said to be feasible. So you'll be able to differentiate between feasible and a non-spontaneous reaction. Let's take welcome you one question and see, test yourself. We will run many questions as we run here. So, is a conversion spontaneous or feasible? And what's the answer? The answer is simple. It is feasible, it's possible, but it's not spontaneous. So, is the conversion ice block to water feasible or spontaneous? The answer is that it is both feasible. It is possible, both feasible and spontaneous. Why it is feasible is that because it can occur on its own. And why it is spontaneous is that it can occur on its own. And why it is feasible that it is possible. So you can be able to picture many other things on it. Now, let me take one technical question. If hydrogen gas is mixed with oxygen under standard atmospheric pressure and temperature, is the reaction spontaneous? The answer is that it is not spontaneous, but feasible. It's not spontaneous because if you mix hydrogen and oxygen, it does not just react. You have to vary the pressure, you have to increase the pressure, you have to increase the temperature. So it is feasible, it's possible, but it's not spontaneous. It will not just occur on its own. So at least I think by this, we should be able to differentiate between the two of them. Let me see somebody writing. High classes honor, formerly known as class. Okay. So that's what you see there. So chemical process can generally be viewed in terms of one. Chemical processes, what we call chemical processes, can be viewed in terms of in terms of one, structure-related function. That's non-physical chemistry. When it is related to structures, chemical structures, it can be organic or inorganic. If it is organic structure, we call it organic chemistry. If it is inorganic structures, we call it inorganic chemistry. Two, it can be seen in terms of equilibrium processes. That's equilibrium processes are processes that are associated with changes. We also have non-equilibrium processes. So we can have equilibrium process, we can have non-equilibrium process. Equilibrium process means that if you change, you will not be able to, it doesn't change with time. The system tries to be at equilibrium. It's neither there or here. It maintains the two systems together. So the processes that associated with changes, that means non-equilibrium is non-significant changes. The processes that are associated with changes are non-equilibrium. So physical chemistry is mostly concerned with equilibrium and non-equilibrium processes. If you alter a small changes, if a small changes occur in a system, or there's no changes in the system, no matter what you do, physical chemistry will be concerned with that. But other branch of chemistry will be concerned with structure-based functions. So that's the difference you can see there. So what is physical chemistry? Physical chemistry is the study of macroscopic and particulate phenomena in chemical systems in terms of what? Principles, practice, and a concept of physics such as motion, energy, force, time, thermodynamics, quantum chemistry, statistical mechanics, analytical dynamics, and chemical equilibrium. These are some of the concepts that are mentioned in physical chemistry. So you can see those are some of the concepts there. So some topics under physical chemistry, which we shall see most of them, inter and intramolecular forces. Maybe if you are looking at sodium chloride, for instance, there will be a force between sodium and sodium, one sodium ion and another sodium ion. You are looking at water, there will be a force between one hydrogen atom and the oxygen atom. Then we can have a force between chloride and chloride. And we can have a force between chloride and water, and then sodium and water. Such are inter and intramolecular forces. So reaction kinetics, study of the rate of chemical reactions. And during the chemical reactions, some chemical reactions that are not feasible can be made to be feasible. And such we say catalysis. So if you add a catalyst, and it now talk about catalysis. So when we study the rate of chemical reaction, we shall see later that a reaction can be first order, it can be second order, it can be third order, it can be fractional order, it can even be zero order. So we have thermodynamics. Thermodynamics is the study of heat change accompanying a chemical reaction, the study of heat change accompanying chemical reactions. And when we are concerned with the heat change accompanying chemical reaction, we can have endothermic. That means heat is given out to the surrounding. And we can have endothermic. That means heat is absorbed from the surrounding. That means the reactant absorbs heat in order to progress. So we can have like the heating of calcium carbonate triocarbonate. It gives you calcium oxide plus carbon 4 oxide. So we can have such reactions, and it's very possible. So the carbon 4 oxide will be given out to the atmosphere. So statistical thermodynamics is also a branch, and it deals with what we call partition function to explain properties of molecules. We have the classical and quantum mechanics, and that deals with Schrodinger equation. We have electrochemistry. Electrochemistry means conversion of electrical energy to chemical energy, or the conversion of chemical energy to electrical energy. That's what electrochemistry does. We have the surface and interfacial sciences, and that is colloid surface tension. It also deals with absorption, phenomenon such as absorption, and then other modeling. We have the computational chemistry, which means we are using computer to bring out chemical results, to solve chemical problems. Whenever we use computers to solve chemical problems, that branch of chemistry is classified as computational chemistry. So we have that, and let's take some questions. A branch of physical chemistry that is concerned with the working of wet cell battery. Wet cell battery is what? The answer is electrochemistry. Partition function is concerned with one of the following. First, partition function I've mentioned is concerned with statistical thermodynamics, and Schrodinger equation is concerned with the quantum chemical, is concerned with quantum chemistry. The principle of solar cell can be seen under that branch of physical chemistry, and that is photochemistry. It can be seen there. It can be seen in photochemistry is the nearest one. We can also see the principle of solar cell in terms of electrochemistry, photochemistry, or electrochemistry. We can also see there. So the principle of solar cell can be seen under that branch of physical chemistry. We have seen that. What are the options? I've already mentioned that corrosion is best explained in what? Electrochemistry. Corrosion is an electrochemical process. Schrodinger equation is applied to quantum chemistry, and so on. Partition function is applied to statistical thermodynamics. So now let's look at unit, basic or fundamental SI unit. There are two types of units. We have the basic unit, we have the fundamental SI unit. So the quantity is length. The unit of length is meter. These are the fundamental unit. That means all other units are derived from them. There are two types of unit. One is called fundamental unit, and the other one is called derived unit. The fundamental unit is a basic one. That means they are the basic unit. All other units are derived from such unit. So we have meter, we have mass, we have temperature. The unit is Kelvin. The unit of mass is kilograms. The unit of length is meter. The unit of time is second. The luminous intensity, the unit is candela. And then amount of substances, the unit is mole. So you can say 1, 2, 3, 4, 5, 6. 6 fundamental units. All other units are derived from them. Let's take a few examples. So let's look at force. Force is defined as what? Mass times acceleration. That means force is equal to ma, mass times acceleration. Now, there are two things there. The unit of mass is what? Kilogram. So we will multiply the unit of mass with the unit of acceleration. And what is acceleration? Acceleration, let's say acceleration, or let's start this way. Let me start with something else. Velocity is defined as distance divided by time. So the unit of velocity is equal to what? The unit of distance is what? Meter. SI unit of fundamental unit of distance is meter. So you divide by time. Fundamental unit of time is second. So that is meters per second. Now we have acceleration. Acceleration is equal to velocity all over time. And that is the unit. That means unit is equal to the unit of velocity. That's meters per second. That's the unit of velocity divided by the unit of time, which is what? Second. So the unit of acceleration is what? Meters per
second square.
Yeah, per second squared. Yeah. So you have that there. So that means force. The unit of force will be what? The unit of mass, that will be, the unit will be what? Unit of mass, which is equal to what? Kilogram multiplied by meters, meters per second. That is given a special name called Newton. Now let's look at a fundamental unit, other fundamental unit. Let's look at work. Work. We can say work is done. The unit, what is work? How do you define work? Can somebody define work for me?
Force times distance, sir.
Force times distance. So force times distance. And that's equal to what? The unit, the same, a special name for force is what? Newton. 1 Newton is equal to kilograms times meters per second squared. So Newton times what? Meter. So the unit now become what? The unit now become what? Newton meter. That's correct. The unit now become Newton meter. So the work done, so Newton meter is given a special name called joule. So that is what you see there. So that is what you see there. So you can now see a pressure is equal to force over area. The unit of force is Newton, divided by the unit of area is meter squared. So that is called, that's the SI unit of this, and it's given a special name called Pascal. So you can do all this for all the units. You find out that the fundamental unit is, in all cases, the fundamental units are listed there. And you can see them here. We shall see more examples as we move on. What is the fundamental and derived unit? Provide example. Can you test yourself? So what are fundamentals? What are fundamentals and derived unit? What are there? What are fundamentals and derived unit? Let me check some chart. This can you see what you are doing? Please, I can see. Okay. Velocity of time. All right, that's good. You are contributing. So provide examples. State the definition. The following symbols use as unit. One of them is Newton. The next one is joule. The next one is Pascal. And you can have something like ohms. Let me put IV. What is ohms? And many of them. So those are special things you can look at. You can look at that. What is the S meaning? The meaning can be related to SI unit. Question, which of the following functions have a derived unit? We have force, velocity, acceleration, none of the above. All of them have a derived unit. Force, you know,
None of the above.
all the above, yeah. So none of the above. So all of the above, you are correct. All of the above. All of the above. So which of the following is not a fundamental unit? A, meter, B, kilogram, C, grams, and D, second. So gram is not a fundamental unit. The SI unit of time is A, second, B, minute. And so you have this, is actually second. The fundamental unit for luminous intensity is what? Candela. So you know it is candela. You can know that it is candela. We don't use it commonly. That's why some of you may not be familiar. The SI unit for luminous intensity is candela. So mole is a fundamental unit for what? Amounts of a substances. It's a fundamental unit for amount of a substance.
Substances.
Yeah, amount of a substance. Amount of substances. Yeah, amount of substances. So that is what it's signed for. Now we have candela here. So we shall also always test ourselves to see our understanding. Maybe we will try to look for some questions and test. So derived unit. Another example, as we have seen, the volume is the same thing as area is the same thing as length times breadth. The unit of length is meter, the unit of breadth is meter. So it's meter square. When we look at volume, we see volume is the same thing as area times the height, and that is meter square times the meter, and that gives you meters cube. So we can meters cube. So we have velocity, distance covered all over time. We have meters per second. Acceleration, meters per second square. Force equal to mass times acceleration. That is a review. Pressure is there, it's given a special, and density is mass over volume. So you have kilogram over meters cube, and then work or energy, force times distance. And we have the SI, you have that kilogram meter square per second squared. That is what you have there. So you have question, derive the unit of the following. That's momentum. Can you derive? Momentum is defined as a mass times velocity. So the unit of mass times the unit of velocity is given as a kilogram per meters per second. So that is a momentum, the unit of momentum. Volume of a gas, V, is equal to the area, volume, area times the height, and that will be area times height of the container it contains, and that is a meter square per meter, and that is meters cube. So the mass of a gas is kilogram, force is equal to Newton, and that is defined as mass times acceleration due to gravity. So we have acceleration and we have potential energy. Potential energy is defined as mass times acceleration due to gravity multiplied by height. And what of kinetic energy? Kinetic energy is equal to half of the mass times velocity.
Squared.
So you can see that unit will be equal to what? Kilogram multiplied by the unit of velocity squared. The unit of velocity is what? Meter per second. So when you square that, you have the unit of kinetic energy, and that is given a special formula called Joule. So that is it. That is also, so Joule can be defined. You can see this will change to kilogram meter square per second square, just like the other one, potential energy. So can you show that? So let's take question. Can you show that
Sorry,
kinetic?
sorry. The
Yes.
formula for kinetic energy, you wrote kg. I thought the thing is ke, like capital letter K.
No, mass. That's a kilo. That's the unit of mass is what? Kilogram. Okay. Meters. The unit of velocity is meters per second squared. Because it's square, you square here.
Okay.
Is that okay?
Okay, sir. Thank you.
So can you show that the unit of kinetic and potential energy is the same? Can you show that is the same? And give a special for the unit. Can you show that? Let me just copy the working here from here. So we have the potential energy. So that is it. If you look at defined potential energy, you see mgh. The unit of m is kg. The unit of g is acceleration due to gravity is m multiplied by s squared. Then that means multiply the unit of height is m. So when you have that. The unit of kinetic energy is half mv squared. You find out the unit is the same thing there. So they are the unit, and the unit is given a special name called Joule. That unit is given a special name called Joule. Prefix for unit. So we can have deci. When we say deci, we use D. We can have decimeter. We can have centimeter. That means 10 to 100 meters. Decimeter means 0.1 meter. Centimeter means centimeter. 100 centimeters make what? 1 meter. So 10 centimeter, 10 decimeter make 1 meter. We have millimeter. We have nanometer, 10 to minus 9 meter. We have picometer, 10 to minus 12 meter. And we have femtometer, 10 to minus 15 meter. Let's take a little walking. Convert 1. 1,000 centimeter to meter. Convert 1,000 centimeter to meter. You know that 100 centimeter. So 100 centimeter is equal to 1 meter. Therefore, 1,000 centimeter will be equal to 100 times 1 divided by what? 1,000 centimeter. No, so yeah, no, 1,000 centimeter will be okay. 1,000 centimeter will be 1,000 times 1 divided by 100, and that is equal to 10
meter.
Yeah, 2.
I know it's 10 meter.
Convert 10 into minus 18 nanometer to meter. So the answer, the equivalent ratio is that is 10 raised to the power of minus 9 nanometer.
How did you calculate this, sir?
Which one? The first one?
No, the
second
last,
one.
the one that you are doing.
I say one. It said convert 10 to minus 18 nanometer to meter, right? We know if you look at the table, the result here, 1 nanometer. 1 nanometer is equal to 10 to minus 9 meter, right?
Okay.
So I'm right. Invariably, I'm telling you convert 10 to minus 18 meter to nanometer. Let me put it straight to you so that you can understand it better. So 10 to minus 9 meter is equal to,
Sir, please, the wipe the screen on time. They wipe it on time. Some of us are taking record of all these things, and
I
so many
will
are.
send it. You have access to the PowerPoint after this lecture. So, but if you can take record better, no problem. So now check it there. 1 nanometer, 10 to minus 9 meter is equal to 1 nanometer. 10 to minus 9 meter is equal to 1 nanometer. Convert 10 to minus 18 meter to nanometer. So the working is, please mute yourself.
That
If you
will be 10
cannot,
to minus 9 times 2.
so 10 to minus 9 meter is equal to 1 nanometer, right? So
Yes.
10 to minus 18 meter will be equal to what?
2 nanometer.
You put it,
2
it will be equal
nanometer.
to 10
2 nanometer.
to
2
minus.
nanometer.
Who is making the noise? Just respect yourself. Mute yourself if your environment is not good. So, because we're interacting, that's why I don't want to mute. It's equal to, that will be equal to that times 1 nanometer divided by what? 10 to minus 9 meter. And you find out that will be equal to 2 nanometers. So if you divide that, you have 2 nanometers. You can try for picometer. So you can try for yourself. Yeah, you can try for yourself. Who is with the radio? Off your radio. You can try for yourself, convert 10 to minus 12 or minus 24, minus 36 meter, picometer. You can convert that. So convert the following to meter. So there are some questions. You can also convert the following to meter. That's 10 millimeter, 10 centimeter, 10 decimeter, 10 picometer, 10 nanometer, and then 10 femtometer. You know femtometer is 10 raised to the power of minus 15 meter. Nanometer is 10 raised to the power of minus 9 meter. This picometer is 10 raised to the power of minus 12 meter. So you can convert that. So some rule, singular. When you're writing the name of unit, you don't write 10 meters. Even if it's 1,000 meter, you won't write 1,000 meters, but you write 10 meters. Something, another example is, you can say, another example 2. You can write 100 second and not 100 second if you want to write there, and not 100 second. That means you don't write plural, you use singular. So spacing between numbers, when you write the number, you give a space before you write the unit, except for percentage. You can write, for instance, meters per second, maybe that means you can write 10 meters, but not 10 m. The 10 m should not just follow the 0. So, but when you are writing percentage, but for percentage, you can write on 70%. That is correct. 70%. That is correct. And not. Who is with that radio? Please off yourself. So that is 70%. So another thing is meters per second, but not meter per second. You don't write meter and then PER. No, not so. You write meters per second, is you write the symbol there. 10 Newton is equal to 10 Newton, not 10 N. You don't write small, you don't use small letters for Newton, you don't use small letter for Kelvin, which is the unit of temperature, and not 200 Kelvin. 0.22 meters and not 0.22 meter. That means 0 must be there. So don't mix degree sign with Kelvin. You cannot write 20 degree Kelvin. You can only write 20 degree Celsius or 20 Kelvin. So you don't mix the two together. That's some simple rules. Conversion between SI and non-SI unit. How do you carry out the conversion? 100 centimeters is equal to 1 meter. What is 1 centimeter? So 100 centimeters is equal to 1 meter. 1 centimeter will be 1 times 1/100. That is equal to 0.01 meter. Therefore, 100 centimeters is equal to that. So 1,000 centimeters will be equal to 10 meters. Convert 200 grams per centimeter to kilogram per meter. So how do you do 200 grams? What is the relationship between gram and kilogram? That means 200 grams times 10 raised to the power of minus 3, because 1,000 grams make 1 kilogram. So 1 kilogram will be equal to what? 1/1,000. That is why you have 10 raised to the power of minus 3 kilograms. So you handle the numerator separately, handle the denominator separately. Now you come back to centimeter. What is the relationship between centimeter, that is the denominator, and meter? You know that 10 to minus 2 meters equal to 1 centimeter. So you are converting to meter. That's why you are looking for meter. So that is it. At the end of it, all your units will appear. So that is what you see there. Question: convert 0.1 meters to centimeter. Convert 600 grams to kilogram. Convert 30 hours to second. You see, hours as a special meaning. You are allowed to use ace, plural, in hours. So you can use plural in hours. Convert 30 hours to minute. So that is a special case. Minute also, the seconds, say minute also can be used in plural form. That's the 2 exceptions. So special unit, force equal to mass and acceleration, and it's Newton. We say that we speak about Pascal for unit of pressure. We have Joule for unit of energy and work, and we have ACE for unit of frequency. Now let's look at instrument. What are the instruments? It's the thing we use to measure units. We have thermometer. We can measure how much coldness or hotness a body, and that is temperature. Barometer for measuring pressure. Balance, it can be analytical balance, it can be top loading balance. When you are coming for practicals, you find out that analytical balance are those that can measure fractional. You can measure up to maybe 0.0001. That's the sensitivity of how useful or how rugged is analytical balance, it depends on the number of decimal places it can measure. But if it cannot measure so much decimal places, maybe one decimal place, we call it top loading balance. So the sensitivity of any balance depends on the ability to measure values in fractions. So the higher the number of decimal places a balance can measure, the more sensitive is that meter or is that balance. Therefore, an analytical balance is more sensitive than top loading balance because it can measure mass with higher decimal places. So that is the difference. So measuring cylinder, we have the volume, we have titration tools. What you use for titration is burette, conical flask, pipette, and the rest of them. So you can have a pH meter for measuring pH. We have electrochemical cell. We have the melting point apparatus. We have the oven. So you shall make use of this during your practicals, the coming practicals. So separation method. There are different types of separation method. The common one is precipitation. We have chromatography, movement of a compound, a component in the mobile phase through a stationary phase. That means in chromatography, we will have one section called a mobile phase and the other section called a stationary phase. The stationary phase is steady, it's not moving. The mobile phase can be liquid moving to meet the solid. Once it meets the solid, something is separated out. That is called chromatography. We have crystallization. You recover a solid out of a solution. Something was a solution, but you now do one thing or the other, and a solid come out from that solution. That process is called crystallization. We also have what we call precipitation. Something precipitate. You add something, and then something come out from it again. So that is another one we call that precipitation. So how can you separate a mixture of kerosene and water? You can use what you call separation funnel. You can use what you call separation funnel. Why? Because one of them will float on top and the other one will be below. Now, it is very good if one of them is colored. So by the time you put all of them in separation funnel, you allow it to stand for a long time. When you tap, you will get one layer, while the other layer remain in the separation funnel. Now, let me ask you a question. What is the principle in the separation of oil from water using a separating?
Hello, sir. Please, how can we be saving all these things from our from this online stuff? How can we be saving it? All these things you are teaching us. How can we be saving it?
The thing is recorded. I think it's recorded. Let me confirm that I've recorded. It's recorded. So there will be a record. You have the record of it. You will be able to have the record at the end of it.
Okay. We'll be able to have the record at the end of the class.
Yeah, at the end of the class, you'll be able to have the record.
Is it on this Zoom or in our portal?
In the course page. In the course page.
Okay.
In the course page, you see the record. You also see
sir.
You also see the PowerPoint on the course page.
All right, sir.
What is the principle in the separation of oil from water using a separation funnel? So you see the principle there is that one layer floats on top of another layer, right? So the answer is separation is based on difference in density. So difference in density makes one, the one that is lighter will float on top, the one that is heavier
have lighter density
under. So that is the difference in density. What we have studied so far, what have we studied? We have studied physical chemistry. What is physical chemistry? That is what is physical chemistry. We have studied different branches of physical chemistry. We talk about quantum chemistry dealing with Schrodinger equation. We talk of statistical thermodynamics dealing with partition function. We talk of reaction kinetics, chemical kinetics dealing with the rate of chemical reaction. We've spoken about thermodynamics dealing with the heat change accompanying a chemical reaction. We talk about some other areas like molecular spectroscopy, dealing with the interaction of matter and radiation. And there are many other ones. So what applications? We have talked about applications of physical chemistry. We have talked about unit, and we say that there are two major classes of unit. We have the fundamental unit, we have the derived unit, and we have some special unit like Newton that have special names. So we have conversion between units. We have talked about that. We have talked about special unit. We have talked about how to solve some problems. And of course, we have talked about the use and principle of separation, of the principle of separation funnel. We have spoken about that. So it's the few minutes, maybe the next 5 minutes, we can take some questions. If you have some questions, not only concerning this particular topic, if you have any question concerning your need, let's have some few times interact. So the floor is open. First of all, let me go through some chat and see. TMA has started already since that. Well, that one you can see in the site where TMA and what link, which link is used in answering TMA. The course page. TMA is on. Please, when is TMA starting? You can also use your phone for recording and screenshot. Well, you have the record here at the end of this. You have the opportunity to have the full record. You have the full video of what we have done. Sorry, sir. Can I see what you are doing? Velocity over time. I'm not understanding. So you have time for question now. You can ask. Any way you want to ask, you can ask. I'm ready.
I have a question.
Hello,
Yes.
sir.
Yes.
Where can we get the PowerPoint from this meeting we just had now?
The course page. Immediately after this, I'll post it to the course page. So when you go to recording, video recording, facilitation recording, you'll be able to see them one after
another. Okay.
I have a question.
Okay.
Yeah, you can ask me.
All right. From this conversion of nanometers, sorry.
Yes.
All right. So we divided 10 power minus 18 by 10 power minus.
Let me take you there. Let me take you there. Wait, let me take you there.
All right.
Now, let me ask you one question. When you understand my question, you'll be able to solve any other.
No, close this.
Right.
Are you hearing me? If the cost of 1 pen is 50 naira, what will be the cost of 2 pens?
It's 100. That the thing is,
it's 100 naira.
when we calculated.
So you now say 1 pen. Now let's take it this way. Let me take it to a simple calculation. 1 pen costs, let's say 100 naira. 100 naira. 1 pen. The cost of 1 pen equal to 100 naira, right?
Yes. Yes.
Will be equal to what? The answer is simply 2 times 100, right? Divided by 1. Divided by 1. Now, if I put it another way, 3 pens cost 150 naira. That means 2 pens will cost what? The answer is 2.
That would be 150. 2 times 150.
But then I want to show 2 times 150 divided by what?
Divided by
3.
By 3.
You understand it that way?
Yes.
Now,
Yes,
a
sir.
similar way is, now the practical way is 1 nanometer is equal to 10 raised to power minus 9 meter. Therefore, 12 nanometer will be equal to what? 12 nanometer times 10 raised to power what? Minus 9 meter divided by what?
1.
1. Now, once you know comprehend this, you can handle all questions. So let me take you to that question. Check yourself. Check your understanding. You can Understand? Please, that
My
noise is
only
not
issue
here.
is that, sir,
Yes, I'm hearing you.
the only thing that I did not get is that when I punched my calculator, 10 power minus 18 divided by 10 power minus 9 is not 2, but
It's what?
10
10,
power
it's
minus
10,
9.
it's 10 to minus what? 9.
10 power minus 9, yes.
Okay, you're right, Tim. You're right. 10 to minus 9 times. Let me see. 10 times all about 10 minus that is 10 minus 9. It's 10 minus 9. Yeah. 10 minus. That's a very good.
Excuse me.
Is that okay? That's okay.
Thank you.
Thank you. Any other question? Any other question? All right. We will end
Excuse me,
today's
sir. When is TMA for Chem 103 starting? When is it starting?
TMA, I think, have you checked the course page? I think is there. If it's not there, within the next 1 week, it will be there.
Okay, sir. Okay, sir. Thank you.
The practical will be within the month, maybe towards the end of the month. You can't
The
say
TMA, right?
no practical class. Somebody asked,
Okay,
when you
okay.
mention practicals of this course, when would that be? Very soon. Within the
Okay, sir.
next 2 weeks.
Good evening.
All right.
Okay.
Have a lovely time till next Saturday.
Okay, sir.
Thank you, sir.
Thank you.
Have a nice time.
Thank you, sir.
Thank you very much, sir. Thank you, sir. Thank you.
So you'll be able to see the video in the course page, be able to see the PowerPoint. Everything are recorded. All right.
Okay, thank you.
Thank you for your time, sir.
Yes, so we
Enjoy your
can
weekend.
enjoy your own too.
Bye.
Bye-bye.
Bye.